All right, we're going to look at the voltage divider rule. The voltage divider rule is really, when you break it down into its simplest form, is a comparison of a total as compared to a single device, or more appropriately, a single device as compared to the total. And you can do that for both voltage and resistance. They are proportional. The difference between them, or more importantly, the ratio between them, is the same. And you can see that in the formula. When you look at the formula up top here, all we're going to do here, is we're going to look at the single resistor, resistor 1 in this case, and we're going to compare it to the resistance total. That will give us a percentage. Whatever percentage resistor 1 is of the resistance total, voltage R1 will have that exact same percentage. And then we just simply have to apply that percentage to our source voltage to determine what the voltage across resistor 1 is. So that's what we're doing when we plunk some numbers in here, is we have 30 volts, and we're going to multiply it by the ratio of 10 divided by our resistance total. Now remember, your resistance total in a series circuit, of course, you simply add them up. So here we're going to compare 10 kilo ohms as compared to 13.3 kilo ohms. And then what we're going to do, whatever that percentage is, we're going to multiply that by the source voltage, and that will give us the actual volt drop across resistor 1. So if we actually do the math, we're going to be taking 30 volts, and we're going to multiply it by the ratio of 10 divided by 13.33, which is 0.75. And when we do that, we get a final answer of 22.56 volts. That means that 22.56, this should be 75% of 30 volts. And you can check that on your calculator by taking 22.56, divide it by 30, and it should come out to pretty close to 75%. If it does, and in this case, yes it does, we know that we've done this correctly. So we can now say then over here that our volt drop across R1 is going to be 22.56 volts. Now we can do the same thing for resistor 2. In this case, what we're going to do is we're simply going to take 30 volts, and we're going to times it by the ratio of 3.3 kilo ohms, and divide that by 13.3 kilo ohms, and that's going to give us a number. So first of all, I got to quit being lazy here. We need to put in here, this is the voltage of resistor 2 is what we're looking for here. Okay, so I'm going to take 30 times our whatever our ratio is. I just have to do it on my calculator here. So 30 times, or sorry, the ratio of 3.3 rather, divided by 13.3 means that it's about 24%. So we'll just write that in here. So we're looking at 0.24 is our ratio. So if we apply that decimal of 0.24 times 30 volts, you should come out to 7.44 volts. And that's our voltage drop across the second one. So we'll go up here and write that in. 7.44. Now if we've done this correctly, and I'm only taking it to a couple decimal places here, these two circled in blue, okay, they should add up to 30 volts if we've done this correctly. Let's add them up and see. 7.44 plus 22.56, and we come out to 30.003. So we have then come out to, for all intents purposes, 30 volts. We've done this correctly.